Hello everyone, welcome to Aryan tutorials on mechanics of fluids and hydraulic machines. This is the second video in which we are going to discuss about basic properties of fluid. So in the previous video we have discussed about the introduction to the mechanics of fluids, in which what is the definition for the mechanics of fluids and what is the definition for a fluid we can give and what are the different types of fluids we'll be having. Okay, so now we have to discuss about the basic properties of fluid. Okay, so what are the basic properties? First I want to list out what are the basic properties we'll be having for the fluid whenever we consider a fluid, whether it may be liquid or liquid or gas. These are the list of the properties we'll have. First one is the mass density or density, and second one is weight density or specific weight, third one is specific volume, and fourth one is specific gravity, and fifth one is viscosity or dynamic viscosity, and sixth one is kinematic viscosity, and seventh one is vapor pressure or cavitations, and eighth one is pressure. Okay, these are the basic properties we can consider for any fluid. So we have to know what is the definition for each and every property. Okay, so in these eight properties, one by one I want to give the definition for the properties. So first we go for the first property is the mass density or density. So how can we define a mass density or density? Means it is defined as the ratio of mass of the fluid to the volume of the fluid. Okay, now so whenever you take one fluid, so how much the amount you are taking, based upon that the density is defined as the ratio of, that means mass of the fluid by volume of the fluid. Okay, by knowing mass and the volume of the fluid we can determine the density, which is one of the properties for the fluid. It can be also defined again as how much the mass can be occupied by the fluid per unit volume of quantity. So that means per unit volume of quantity how much the mass it will be consisting of, that is defined as the mass density or density. So mass occupied by fluid per unit volume is the density or mass density. So it can be represented by the rho. So the formula can be written as rho is equal to, according to the definition, mass of the fluid by volume of the fluid. Okay, which will be the mass density or density. So here mass can be represented by small m and the volume can be represented by capital V. Okay, so here before that we can give the units for the mass density. So what are the units we can give for mass density? Means here mass is kg and the volume is meter cube. So kg per meter cube is the unit for the mass density. I didn't show here, so please remember the units for the mass density is kg per meter cube. So next property is weight density or specific weight. How can we define weight density or specific weight? Means similar to the mass density, only here also it is defined as the ratio of weight of the fluid to the volume of the fluid. Okay, again we can define the same definition as how much the weight can be occupied by the fluid per unit volume of quantity is called as weight density or specific weight. Okay, and the same formula here it is represented by the symbol small w, and small w is equal to weight of the fluid by the volume of the fluid. So again representation is W by V, and the units are, units for the weight is Newton and the units for the volume is meter cube. So finally we can write it as Newton per meter cubes is the unit for the weight density or specific weight. Remember that. So next thing is we have to know, we can modify the equation. W by V can be modified. So how can we modify it? Means here the weight W, this W can be written as, what is the weight formula? Weight formula we can write it as mass into gravitational acceleration. So similarly write down here mass into gravitational acceleration by V. So when you keenly observe this formula, mass by volume, already just now we have discussed what is the density definition. It is the ratio of mass and the volume of the liquid. So m by v can be written as rho. So finally we can write the W is equal to rho into g. So specific weight can also be written as the product of density and the gravitational acceleration. So this is the relation important while solving certain problems when you are studying the fluid mechanics. Okay, now here again units will be same, Newton per meter cube only. Okay, so now we have to discuss the third property is with specific volume. So the definition for the specific volume is the ratio of volume of the fluid to the mass of the fluid. So that means here how much the volume can be occupied per unit mass of the fluid, that is called as here specific volume. So another way of explanation, just now I told you the volume occupied by the fluid per unit mass of the fluid is called as specific volume. So if you observe this definition is opposite to the definition of the mass density or weight density. So mass density is the ratio of mass to the volume, but here specific volume is volume per mass of the fluid. Okay, so the formula can be written as, again it is represented by the symbol nu. Okay, nu is the symbol, sorry, small v, sorry, not nu, small v is the symbol which is used for representing the specific volume. Okay, so specific volume can be written as volume of the fluid to the mass of the fluid. So ultimately we can write it as V by M, so which can be again written as, already we know that rho is equal to mass by volume, so that this can be also again defined as the reciprocal of mass density. So V is equal to, we can write it as 1 by rho. Okay, that is about the specific volume, okay, which is the reciprocal of mass density. Okay, now so up to this, okay, these are the three basic properties we are having. So in the next property, the next property we are going to discuss is specific gravity here, ma. Okay, so specific gravity, how can we define, means again it is defined as the ratio of mass density of the fluid to the mass density of the standard fluid. It can be defined as the ratio of mass density to the mass density of standard fluid. Okay, so that means here the ratio we are taking between the two similar quantities, so which is the dimensionless quantity. Okay, now so in this condition it can be also defined mass density in terms of mass density, we can define, again we can define in terms of weight density also. It can be also defined as weight density of the fluid to the weight density of the standard fluid. Either it is a mass density we can consider or weight density we can consider. The formula can be written as with the representation of the symbol S. So S is equal to, we can write it as weight density or mass density of the fluid which we are going to study. Okay, by weight density or mass density of the standard fluid, which the water we take it as standard fluid. Okay, now so the ratio of weight density or mass density of fluid to the weight density or mass density of the water is called as specific gravity, which is the dimensionless quantity. Okay, now so because we are taking the ratio in between the two similar quantities, so that due to that it is a dimensionless quantity. Okay, so up to this, okay, ma. So up to now we have discussed the four basic properties of the fluid. So in the next video we study about the viscosity of the fluid, which is very very important. We have to understand about the viscosity. How can we define the viscosity, and how can we find the viscosity by analyzing the flow of the fluid. Okay, now so that viscosity we discuss in next video. So I hope you understand up to this. So if you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video, and please subscribe to my channel. So thank you all.